All right, guys, I'm not here today, so this is a video you need to watch. Pause it as much as you need to. I'm not going to stop and wait for you to write stuff down. I'm going to keep talking through everything. So pause it, write down what you need. If you don't write all the words, make sure you write enough to get the point across so you understand what's going on. All right, we'll talk about the homework from section 2-4 on Tuesday. The quiz will also be on Tuesday. There are 2 videos. The second video was filmed a long time ago during COVID. So if I'm talking about things that have nothing to do with us, just ignore them. Just worry about the math. All right, so today's lesson is going to be the rational zero test. All right, in a roundabout way. All this says is this is a polynomial. All right, an ugly way to write one, but it's just a normal polynomial like number 1. If it has integer coefficients, no fractions, no decimals, then every rational zero, which are going to be our good-looking answers. Rational zeros are numbers that are written as fractions. No square roots, no imaginaries. So every rational zero of our function can be written as what we're going to call plus or minus p over q. Plus or minus p over q is going to give us a list of numbers that might work. They might be good zeros for our function. We just have to find out. P is going to be the factors of my constant term, the number in the back. Q is going to be the factors of my leading coefficient. All right, so we're going to make a list of terms that might be good-looking answers. All right, so number 1 says without graphing, find the rational zero. So if I have f of x equals x to the third plus x squared plus 2, I'm going to do plus or minus p over q, which is plus or minus my factors of 2, which are 1 and 2, divided by the factors of my leading coefficient, which is 1. So I'm going to write plus or minus 1 and 2 over 1. I'm going to write each of these fractions, 1 over 1 and 2 over 1. So what these are 4 potential answers, rational answers for this function. And what we have to do now is our synthetic division to find out which ones are zeros of this function, which are rational zeros, which means I get a remainder of 0. So what I'm going to do is I'm going to pick a number. I'm going to try positive 1 first. Coefficients of my x to the third is 1. On my x squared is 0 because I don't have an x squared. 1 and 2. All right, so doing my synthetic. 1 times 1 is 1. 1, 2, 2, 4. Nope, doesn't work. All right, we got to get that remainder of 0. So I'm going to start over. 1. I'll try negative 1. 1, 0, 1, 2. 1, negative 1, negative 1, 1, 2, negative 2. Yay, I got my answer. So I picked one of these at numbers because this function could have up to 3 answers. So I found one. One of my solutions is going to be x equals negative 1. Now I'm going to take this, which is my x squared, my x, and my number, and write 1x squared minus x plus 2. Set it equal to 0. I'm only after the good answers on this problem. So if it factors, I can get good answers. If it doesn't, I'm not worried about them yet. So looking at this, what numbers multiply to give me 2, add to give me 1? Nothing. So this doesn't factor. So the only rational solution I have is negative 1. So again, what we're going to do, we're going to make a list of possible good-looking answers. No square roots, no imaginaries. By doing plus or minus p over q, the factors of 2 divided by the factors of 1, which gave me these 4 right here. I did synthetic division. Positive 1 did not work, but negative 1 did. So I took my x to the third and changed it to an x squared. I looked at my x squared minus x plus 2, which is left over. It doesn't factor at all. So that means that's my only good answer. If it factored, we would find more good ones. That's our idea for today. So the only new concept, the only thing new we got to worry about is how to find these possible rational zeros. All right, so let's do the same thing for number 2. Plus or minus p over q. Plus or minus the factors of 3 divided by the factors of 2. Writing all these combinations, plus or minus 1 over 1, 1 over 2, 3 over 1, and plus or minus 3 over 2. So there's 8 potential answers, but at most there's going to be 3. So out of those 8 numbers, I need to find one of them that works. All right, so you would do synthetic division. I'm just going to start picking numbers. I'm going to try -3 first, just because. So I go 2, 3, -8, and 3. For this to be one of my solutions, remember, I need 0 as a remainder. 2, -6, -3, 9, 1, -3, and I got lucky and got it the first try. If you would have picked different numbers and got another number that works, that's fine too. Your math from there would just be different. So now, one of my solutions is -3. I'm going to take 2x squared minus 3x plus 1, set it equal to 0, and see if I have any more. Our options are to factor, quadratic formula, and we probably wouldn't complete the square. But if it gives it using the quadratic formula, and you get i's or square roots left over, they're not good ones. So I'm going to factor this. All right, so minus 2 is 1 and 2. So 2x squared minus 2x minus 1x plus 1. I'm factoring, because it is going to factor. 2x, leaving behind an x minus 1. Take out a -1, leaving behind an x minus 1. 2x minus 1, x minus 1 equals 0. X equals 1/2 and positive 1. So I got my 3 answers. If you would have done synthetic division with either of these two as your first guess, you still would have got a remainder of 0, but the rest of the math would have been different because you took out a different one first, but they all would have factored, and they would have all given you all 3 solutions. All right, so when there's 3 that do work, 3 good ones, you only have to find 1, because once we find 1, we're going to get an x squared over here, and we know how to solve x squareds. All right, so an x to the third, we need to take out one good one to get it to an x squared to be able to finish it. Like I said, I'm going to talk fast and get through this. You need to pause it and do the work ahead of me instead of just waiting. All right, whole bunch of words up here. You need to write enough. All right, I'm going to talk quick through them, pause them whenever you need it. All right, the fundamental theorem of algebra says if f of x is a polynomial function of degree n, where n is greater than 0, which means my largest exponent is greater than 0, that function f has at least one 0 in the complex number system. We talk about this. If my function is 3x to the third with a whole bunch more after it, this function could have up to 3 zeros because of the x to the third, but it has to have 1. All right? That's the rule. Fundamental theorem. We've talked about it. Could have 3, has to have 1. Every polynomial has 1 0. Could have more, but it has to have 1. The linear factorization theorem says degree blah blah blah, if f of x is a polynomial degree n, f has precisely n linear factors. This x to the third has 3 factors, has to have 3. An x to the 7th has to have 7 linear factors. Linear factors are just x's, not x squareds, but x's. All right, so linear factorization theorem says 3x to the third has 3 linear factors. And the last one, the complex zeros occur in conjugate pairs. We can all read that, but all this one says is if we have one imaginary answer, a plus bi, we automatically get the second, a minus bi. Imaginary answers always come in pairs. 1 plus I gives you automatically 1 minus I. Always. Negative 3i always gives you positive 3i. I's come in pairs. Complex zeros occur in conjugate pairs. X to the third has 3 factors. Fundamental theorem of algebra, 7x to the 5th has at least 1 0, but could have 5. We've talked and used all of these before. All right, now I'm going to ask you to find all the zeros. And then we're going to write them as a product of linear factors. So we're going to find zeros and write factors. So to do this problem, I'm going to solve it. 23 doesn't add, nothing multiplies to give me 23, adds to give me 10. So that tells me I'm going to get some uglier numbers, some square roots, some imaginaries. We can quadratic formula, we can complete the square, but I'm going to complete the square because I think it's going to be easier. If you quadratic formula, you're going to get to the same answer. All right, so x squared plus 10x. I'm going to take half my middle, square it, and put it on both sides. I'm going to plus or minus square root the 2 and square root the right side. I'm going to subtract the 5 and get my 2 answers. So my answers are going to be -5 plus the square root of 2 and -5 minus the square root of 2. Those are my 2 answers. Quadratic formula would get you to the same place. So we found the zeros. Now as linear factors, we all know that if I have a solution to write the factor, we do the opposite. So if I have x or -5 plus the square root of 2, I'm going to go x plus the square root of 5 minus the square root of 2. It's the complete opposite. I don't need square roots in there. X plus 5 minus the square root of 2. The opposite. Then x plus 5 plus the square root of 2. Those are my linear factors. So after we solve, however we solve, we take our solutions and do x in the opposite for our factors. All right, last one before we go to the next slide. All right, number 4. F of x equals x to the third minus 3x squared plus 4x minus 2. I don't know how to factor that. But I need to find up to 3 answers, and I have to find 3 factors. So since I can't factor it, I'm going to do plus or minus p over q. So plus or minus the factors of 2 over the factors of 1. So my possible answers are plus or 1, plus or minus 2. So p over q gives me a list of my possible good answers. All right, so now I need to start doing synthetic division. Try 1, 1, -3, 4, -2. 1, 1, -2, -2, 2, 2, 0, and it worked. Now I'm going to take this, since I took out one answer is going to be x equals 1, so I have my factor x minus 1. X squared minus 2x plus 2 equals 0. What's left over? I'm going to complete the square because that's what I like to do. X minus 1 squared plus 1 plus 1 equals a -1. Square root plus or minus square root. X minus 1 equals plus or minus I. X equals 1 plus or minus I. So my other solutions, just so I can see it better, 1 plus I, 1 minus I. Now that I have all 3 solutions, I put the opposite into the factors. That's my product of linear factors. All right, so we're going to have to find potential good answers, plus or minus p over q. Synthetically divide them out. Get it down to an x squared, and work with what you have left. All right, there's another video you need to watch. If you have questions and this doesn't make any sense, talk to the people around you. When you start doing your homework, you can ask me a question in WebAssign. I can't promise I'm going to answer it, but I'll do my best. And hopefully we understand what's going on. But we'll talk about both homework assignments on Tuesday when we come back, and we'll take our quiz. Have a good day.